All right, boys and girls, this is the Chapter 8 test review. And these back questions are word problems that are going to be similar to what you see on your test tomorrow on the back page of your test. You know, on the back page of your test, it's always word problems, right? These are going to be similar, okay? They're not going to be the exact same questions, but they will be similar. So you need to pay attention and see how we work these out so that you can maybe know what to do tomorrow. Understand? Okay, let's read number 17. Destiny has 6 library books on her desk. 1/3 of them about animals. How many of Destiny's library books are about animals? Draw a diagram to show your work. Boys and girls, this problem is exactly what you did yesterday. Exactly what you did yesterday. So, what do we know? What is the most important thing we do for first step? What's the first step?
We draw 6 circles.
Why?
Because that's how many, that's how many we find.
Okay, but where do we find that at?
We find that
In the 1/3, which is the fraction, guys. You find that in the 1/3, which is the fraction. Yes, you were right, Cooper. You were right. I'm just showing you where everybody finds them. 1/3. Now, 1/3, boys and girls, in a fraction means you put a 1 on top of a 3. And the 3 is the denominator. The denominator tells you how many equal parts or how many equal groups. So like Cooper said, you are drawing 3 equal groups. Okay, second step. Now we have used the fraction. Now I need to use other information. What is my second step now? Jacob?
draw circles.
We call them something else, not circles, but counters. Thank you. Draw counters. But how many? How do I know? Look at the problem. How many? How many counters would I draw on the group? Tyson? No? Not 2. No? Oh. No, you're right. 2. Sorry. Tyson is right. That's not quite how we worked these out yesterday. But it says she has 6 library books on her desk. So you can't have any more than 6. Because she only has 6 on her desk, correct? So how many have to go in each to make all those equal? 2. Tyson was right on this one. This is not quite how we worked these out yesterday. Okay, so 1/3 of them. That means one group out of the 3 groups are going to be about animals. So we're going to do this one. How many of her books were about animals then, guys? Okay, let's write that to what? Okay, write that down. Number 18. Julian made a flag for his clubhouse. What fraction of his flag is green? Explain how you know. Okay, what are we going to be writing on this one? What does the question ask? What fraction? So what's the answer going to be?
A fraction.
A fraction. Not a whole number like this. It's going to be a fraction. So look at this. What is this showing? What fraction of it is green, the question asks. Green. Okay, so let's remember, if I'm writing a fraction, that means I have to have a top and bottom number, right? A numerator and a denominator. What do the denominators always tell us, Callie?
What it is split into?
Yes, what is this split into? How many pieces is this split into? Equal pieces. They are all the same size. How many equal pieces is this split into, Savannah?
8.
And where does that go again?
Where the denominators go.
On the denominator, which is the
Bottom.
bottom. So 8 is going to be the bottom number. Now the question says how much of it is green? So that's where you count on the top how much of it is green. How many of those parts are green, Bella?
2.
2. So now we have gotten our fraction. Now how do we get that fraction? So we need to say first and what did we look at first, guys? Counted equal parts. Counted, we're going to say 8 equal parts. Equal parts. And what would that be? It's our what?
Denominator.
Or the denominator. Good. Find the next one then. We looked at the what?
The green.
The green parts. The numerator was the number of green parts. Or we'll say the numerator was the 2 green parts. The numerator was the 2 green parts. Taylor baked a cake to serve after dinner. Okay, so it's a cake. Cake's usually a round or something, right?
Yeah.
Okay, suppose she cut the cake into 8 equal sized pieces, and 6 people ate all the pieces. Explain how you could have divided the pieces so that everyone ate the same amount of cake. You may show your work in a drawing. Okay. So, it says she cut the cake into 8 equal pieces. Can we draw that?
Yeah.
Okay, let's do that. Draw a circle. Make a plus sign. And then make an X go through the plus sign. That's 8 equal pieces.
I do it.
Okay? And then we will probably put what on these to show people?
Numbers.
We'll put numbers on these to show people. So 1, 2, how many people were there?
6.
3, 4, 5, 6. Okay. So let's explain what we did first. Okay? First, I showed every person getting 1 piece of cake. Okay, we said there are 2 pieces left over. Okay, boys and girls, I want you to think of blocks. Kind of. They need to share. Those 6 people need to share those 2 pieces. How much of those 2 pieces would they get? What would you split those 2 pieces in? You split them into fourths? Okay, if you split them into fourths, I'm just going to show you. Okay, let's say these are the 2 pieces. You split them into fourths. 1, 2, 3, 4, 5, 6. That's not going to be equal. Okay, so we're going to split those 2 pieces. I know they're not square, really. But how could we split them then, Carter?
Into thirds.
Into thirds, which is what Cooper said too after he changed his mind. Okay, so let's say we're going to split the 2 pieces into thirds. We will each person get it if they're split into halves? Okay, let's look. You split 2 pieces in half. Will 6 people get to have a piece? 3/4. No, 2 people will get left out. That's not equal. 6 people, if you split it into 2/3, will get a piece. You have to split it into 2/3. Okay, we will split the 2 pieces into 1/3. Okay, so how many whole pieces will each person get?
1.
Okay, so it's like, so each person will get 1 whole piece. Okay, so each person will get 1 whole piece of the cake plus what? Of the other 2 pieces. They get, Eli?
1 more piece.
No, they don't get 1 more whole piece. These are.
Oh, they get 1.
1 what?
1/3.
1/3 of another piece. And 1/3 of another piece. Okay, and okay, suppose there are 2 pieces of cake left over, but you don't know how many pieces were in the whole cake. Explain how you can find the number of pieces in a whole cake if Taylor told you that 1/6 of the cake was left. You may show your work in a drawing. Okay, so we know how much is left, and we know, which is 2 pieces, and we know those 2 pieces are 1/6, right? So this is going to be kind of like this problem, number 17. Okay? So 1/6, what does that tell us? What does 1/6 tell us, guys?
There's 1 shaded and 6 equal.
There are 6 equal groups. So let's do that. So yes, we're going to draw 6 circles. Try to draw them maybe a little small up here so that you guys have room just in case you need to write a lot for your explanation. All right, we said, we looked at the denominator of the fraction of 1/6. And the denominator is 6, so we drew 6 equal groups, which is the 6 circles. Okay, now my question is, we have 2 pieces left over, and those 2 pieces are supposed to be the 1/6. So how many counters am I going to put? And where am I going to put them? Listen. So 2 pieces equals 1/6. The 6 is how many groups we draw. The 1 up here is how many groups will have the 2 in it. So you put 2 dots in 1 group. Now, that's not going to tell us how many altogether, though. What do we need to do to tell the whole total that was there, even not just what's left, but what was there before everybody ate all the cake? Callie, what do I do?
You put 2 in each circle?
Yes, then you add 2 counters to each circle to show the total. What would that total be then?
12.
12. Okay, we're going to write all this problem down. Okay, so we said we have the denominator with 6, and so we'll draw 6 equal groups. I put 2 counters in 1 group for the 2 leftover cake pieces. So that's what we did right here, this group. To find the total number of pieces, though, I needed to draw 2 counters in the rest of the groups. And then I found out there are 12 counters in all, which are the 12 pieces of cake that there were to begin with.
So to find the